Let's continue our discussion of game graphics concepts. Our focus will be on the model layer of the graphics display model. The model layer defines how the graphics are represented internally within the game or software. There are two primary graphics models, bitmap and vector. A bitmap image stores the color information about each pixel in the image. Therefore, this is sometimes also referred to as a pixel map. So, for example, the image shown is a 10 pixel by 10 pixel image, or essentially 100 pixels of color information, where some pixels are white and some pixels are blue. The resulting image, when viewed at a distance, looks roughly like a circle. The color information is made up of a certain number of bits or binary information. So 1 bit of information per pixel would allow you to define just 2 different color choices, whereas 8 bits of information per pixel would allow you to have up to 256 colors of information. Most images we work with today in games are 16-bit, 24-bit, or 32-bit, depending on if the image has transparency information included, which is called an alpha channel. Bitmap graphics are the most direct graphical representation to what you see on the display. That is, a bitmap image is often directly rendered to the display. Obviously, you can scale a bitmap image up, but the visual quality will diminish as you are just zooming in on the pixels that are available. You're not creating new pixels. Bitmap images can be used not only for 2D graphical elements such as game sprites and user interface elements, but also for texture maps on 3D elements, as we saw with our previous Unity project. To achieve high frame rates in our games, the pixel dimensions of bitmap images should usually be made to be a power of 2 to help take advantage of the efficiencies this allows in the graphics processing unit, or GPU. You don't have to make your images square, but both the width and height should be a power of 2, such as 512 pixels wide by 256 pixels high. While non-power of 2 images are possible, they may slow down performance of your game and should typically only be used for user interface elements. Vector images are stored internally as geometric information, or in essence, mathematical equations. So instead of storing the color information for each pixel in an image of a circle, we represent the circle internally as a coded equation within the software, such as image equals circle with radius 5 and border 1. Of course, we usually are making much more elaborate vector images through the use of geometric primitives, curves, and gradient colors. Using vector graphics tools, artists can easily create a fun cartoon look without having to know any math. Vector images have the advantage over bitmap images in that you can scale them up without the image becoming pixelated. That is, vectors scale without losing image quality. However, vectors have the disadvantage of taking longer to render than bitmap images. When the vector is displayed, it is first converted into the desired sized pixel image, and then rendered to the display. This extra step of converting the vector into a pixel map takes computer processing time. While some game engines such as Flash do support vector images, bitmap images are often used in games when high frame rate is desired. However, vector images still have their place in game development. For example, 3D graphics are essentially vector graphics in 3 dimensions. That is, a 3D model is defined by geometric polygons to create the mesh of the model. The more polygons that are used, the more detail that can be displayed. Or stated another way, the more organic or smooth the model will look. When rendering the 3D graphics, the graphics processing unit in the computer hardware often converts the polygons, which may have several vertices, into triangles for efficiency purposes. The more polygons, the more triangles, the longer it will take the computer to render the 3D model. Therefore, in game development, when we want real-time rendering of 3D graphics, we often try to limit the number of polygons or tries, or we use what is called low polygon modeling, so that the game runs at a high frame rate. In the next video, we'll talk a bit about graphics file formats.